Grade 9 Physics, Chapter Gravitation, Module 2. Objectives: to identify the relationship between Newton's third law of motion and gravitation, to define free fall, to find the value of acceleration due to gravity. Newton's third law of motion and gravitation. Newton's third law of motion says that if an object exerts a force on another object, then the second object exerts an equal and opposite force on the first object. The Newton's third law of motion also holds good for the force of gravitation. This means that when Earth exerts a force of attraction on an object, then the object also exerts an equal force on the Earth in the opposite direction. Suppose when a stone is dropped from a height, it gets accelerated and falls towards the Earth, and we say that the stone comes down due to the gravitational force of attraction exerted by the Earth. Now, if the stone also exerts an equal and opposite force on the Earth, then why don't we see the Earth rising up towards the stone? Let us discuss. We know that from Newton's second law of motion, F equals ma. That means F is equal to mass into acceleration. So, acceleration is equal to force by mass. It is clear from this formula that the acceleration produced in a body is inversely proportional to the mass of the body. Now, the mass of a stone is very small, due to which the gravitational force produces a large acceleration in it. Due to the very large mass of the Earth, the same gravitational force produces a very small acceleration in the Earth. Since the acceleration produced in the stone is quite large, we can see that the stone falling towards the Earth. But since the acceleration produced in the Earth is extremely small, we cannot see the motion of the Earth towards the falling stone. Free fall. The falling of a body from a height towards the Earth under the gravitational force of Earth is called free fall. The acceleration produced in the freely falling bodies is the same for all the bodies and does not depend on the mass of the body. Acceleration due to gravity. When an object is dropped from some height, its velocity increases at a constant rate. In other words, when an object is dropped from some height, a uniform acceleration is produced in it by the gravitational pull of the Earth, and this acceleration does not depend on the mass of the falling object. The uniform acceleration produced in a freely falling body due to the gravitational force of the Earth is known as acceleration due to gravity and is represented by the letter g. The value of acceleration due to gravity, g, is equal to 9.8 meter per second square. The value of g changes slightly from place to place, but for most of the places it is taken as 9.8 meter per second square. When a body is dropped freely, it falls with an acceleration of 9.8 meter per second square. And when a body is thrown vertically upwards, it undergoes a retardation of 9.8 meter per second square. This ball is falling to the ground under the action of Earth's gravity. Its velocity is increasing at a constant rate of 9.8 meter per second for every second of time it is falling. In this module, you have learned about relationship between Newton's third law and gravitation, free fall, and acceleration due to gravity.